The most modern airplanes that we have in the world today are Airbus airplanes. Looking forward, we will see that the A350 family will expand with the 1000 and the 800. We will see the 330s continue to be offered to the airlines because we've kept the aircraft alive with all the new technology innovations that we've put into the airplane. We'll keep the 320 going with the NEO because that's what the customers want. And then we will start our research, and we've already started our research into looking at, for 2030 and beyond, how will we look at replacing. It's a very difficult airplane to replace the A320neo, but we will have a continuous innovation, continuous development of the airplane, but we will have to look to the future and see what else that we would have to do to keep that airplane in the marketplace. The A380, as I already mentioned, we will also look at that aircraft and what we have to do in terms of innovation, and again, continuous innovation in terms of development of the A380. In terms of the technologies that are available to us, of course, the engine technologies will continue to evolve. We typically see a 1% increase in fuel burn for every year that goes by. We will look at the counter-rotating propellers. We look at higher bypass ratio engines. We look at evolutions of the sharklet that we have on the NEO. We look at new materials. We look at connectivity. All of these things are currently being investigated and will be applied to aircraft, not just the airplanes that we have in service today, but for the future airplanes going forward. It's not all about the airplane. It's also about how we deliver the airplane and all the services around it, which will become more important as we go through in the future. We will look at the Flight Hour Services Agreement. I already mentioned that we have the world's leading customer support department. Well, we don't just support the airplanes anymore at the time of entry to service. We actually have contracts with some of these airlines which actually look after the aircraft for the next 5, 10, 12 years going forward, where we take the responsibility of looking after the airframe, we take the responsibility for looking after the components of the aircraft, not just from a sort of maintenance cost guarantee point of view, but actually the operational, day-to-day operations of the aircraft. We look at upgrades. If you look at the A320s today, we have the sharklets on the current aircraft. We look at adding the sharklets to the previous airplanes. We'll upgrade the airplanes. When we change the cabin, when we modernize the cabin of the aircraft, we offer the airlines upgrade services to upgrade their older aircraft into the more modern. When we look at the A330s being developed, today we start with 238 tons today on the takeoff weight. We would look to add the takeoff weight to some of the airplanes that have already been delivered when we get up to 242 tons and beyond. We look at airport operations. You heard today from my colleague about the services that we do with air traffic control management. Well, it is important to us because if we can improve the air traffic management around the world, then the aircraft will flow easier, the airlines will make more money, the airlines will buy more aircraft. So ATM is another business that we've got into. Training, we have our relationship with CAE today, but we'll look to evolve the training relationship that we have with the airlines going forward. And connectivity, very interesting to see what business models would exist where Airbus would participate not just in making the aircraft connected in terms of delivering not just from a passenger entertainment point of view, but also from the services of the aircraft, its maintainability, its faults, etc. All that connectivity is something that we will look into going forward. So there's, apart from the airplane, there's a lot of new services, a lot of new areas that Airbus is investing and developing its expertise to cope with the challenges that we will face into the future. So, in general, we have a very modern family of airplanes, the most modern family of airplanes. The aircraft are extremely competitive. We can see that Boeing has a very tough challenge to match our capabilities that we're already delivering. We see that the 787 family on its own can't do the job. They have to bring in the old 777 and try and make it an airplane that can compete. We know that the only way they can do that is to add more seats or to make the aircraft more uncomfortable or to make the aircraft less compatible with the airports. We know that the 747-8 is struggling. We know that the airlines who've already taken it want to replace it almost immediately. We know that we have 60% market share when it comes to the 320neo against the 737. We know that we're delivering not just airplanes, but we're delivering world-class customer support. And we know that we're delivering not just support, but actually entering into partnerships with the airlines to ensure that the aircraft are not just maintained, but are maintained to the highest standards, delivering safe operations and efficient operations and delivering sustained profitability for our customers. So that's what we're all about, and if there are any questions, I'm here to take them from that.
Thank you, Kieran. I couldn't have summarized this event better. Really great. Questions to Kieran? Oh.
They all want to go home.
It's not enough coffee, so Sebastian.
Hello, Sebastian Schein from Flugverbot. I would like to ask you, please, about upcoming technologies in commercial airplanes.
Yeah.
What would you expect to come next? I mean, earlier today we were debating the question of turboprop aircraft. You have a brand new turboprop, the A400M.
Yeah.
Is this something you are considering for the next generation single aisle as a power source? Or maybe let's include all the new jet versions with open rotors and whatever.
Sure.
And what role will electric energy play for airplanes? You will be able to taxi backwards and whatever you like, just on electrical power. Then, thank you.
Okay, well, let's talk quickly about the electric power. So we have e-taxi, which has been developed by Honeywell and Safran. Very impressive project. Been to see the aircraft. Adds a couple of 100 kilos to the weight of the airplane, but allows the airplane to push back itself, allows the airplane to taxi to the point of takeoff, allows the airplane to taxi back in on APU and electric power. It saves in the region of 3 to 4% of fuel based on, let's say, a 600-700 nautical mile mission. When we think that the Sharklets were delivering about 4% on about the same sort of missions, we can see that e-taxi will have a similar impact and a positive impact in the industry. We have the similar technology, or the similar application, which is the taxi-bot, which is something which we've invested in so far, more applicable to the long-haul airplanes because you're not attaching any weight to the aircraft, but that's where the taxi-bot is towed, pushed back and towed to the end of the runway under the guidance of the captain of the aircraft. And there again, we're talking about 1 or 2% savings in fuel. 1 or 2% may not sound like a lot, but on an A380, 1% of fuel represents about $4 million worth of value to an airline. On an A320, 1% represents about 1% or $1 million in terms of value. So you can see that these electric taxis or taxi bots will come into the marketplace, and the airlines will start to save fuel, save emissions, save noise on the ground using these technologies. You talk about turboprops, and it's actually a very important subject for me, as I just recently became chairman of ATR. And you know that ATR is 50% owned by EADS and 50% owned by Alinea. If we look at that marketplace, back in 2000, we almost saw ATR going bankrupt. There was nobody who wanted to buy an ATR back in 2000. They had a backlog in those days, which were in a handful of airplanes. But then fuel prices started to go up, and when fuel prices started to go up, the ATR proposition became very impressive as far as the airlines were concerned, because when comparing an ATR to a regional jet, you save about 20 or 30% fuel burn per seat. Now, those regional jets have improved over the last few years. We've seen the C-Series coming onto the marketplace. We see the E-jets coming from Embraer. We see the new jets coming out of Japan, and of course, China as well. Those airplanes have moved the regional jet market in terms of their fuel efficiency. So that's still not as efficient as the turboprops of 30-year-old design. But if we want to look for 2020 and beyond, we will naturally look to improve the turboprops, not just in terms of the efficiency that the new engines, the new technology can bring, but in terms of the size as well. It used to be a market which was in the 30 to 40 seat category. It moved from the 40 to the 70 seat category. The next step, we'll see it moving from the 70 to probably the 90 seat category and maybe beyond. Because if we look at the efficiency of the small jets, the 737-600, the A318, for example, those airplanes have a difficult time in high fuel burn, high fuel cost environment. And so the turboprop then starts to become a better proposition than even the 110, 120 seat jet. So I think we've seen the turboprop market more or less kill the regional jets. And what we will see now is that we will see the turboprops looking to evolve into larger airplanes, quieter airplanes, more vibration, more modern aircraft, more comfortable airplanes, bigger overhead bins, underfloor storage for the